Good morning, ladies and gentlemen. I think we need to start. We have 2 hours for our discussion. We'll still have time to enjoy one another. We're talking about SCADA security issues, a very popular topic. We'll try to speak about something interesting. Are there any people here from SCADA metrology? So mainly two. So it's going to be a traditional formal. When one security expert will be speaking about how to protect SCADA systems to other ones, although you are not really involved into it. So we, together with the organizers, have tried to invite representatives of different interested parties, and we have the vendors present here, and we have SCADA solutions representatives, integrators present here. So I hope that we'll be able to discuss the items which may be interesting for us. So could you please introduce each other? So I would like to give the microphone to you and introduce yourself. MT Group, Alexey Malyev. Alexey Etkin Emerson. Hello, colleagues. Vladimir Karantayev, Infotex. Anton Shipulin, Kaspersky Lab. Andrei Bershatsky, Positive Technologies. Anton Vasilyev, Bombardier Transportation Signal. My name is Ivan Melekhin from Inform Защита. I think Vladimir Podolnych is going to join us soon. So let us start, and we have Anton Shipulin's presentation from Kaspersky Labs. Actually, that's the format that we're going to embark upon. First of all, we're going to have short presentations for the first hour, and the second hour will be dedicated to the dialogue. In my presentation, I will be briefly speaking about the experience, our experience of using our solutions at a facility. I will skip the marketing part and just briefly explain and tackle on the events and the specifics of such events in a facility that we had to deal with. We had an experience of implementing security systems in a Taneka refinery facility. It was a successful implementation. We protected a technological process of gas oil unloading from railway cars, railway tanks, to the storage depot system. The gas oil was discharged, transported to the storage depot, and when the railway cars were missing from the site, the gas oil was being cycled there, heated. The main attack object in this technological process is to be the system automation system, the controllers. We considered such negative impacts as the changes of the settings of the controllers, changes of the tolerances of the sensors, meters and gauges, and other changes in the controller settings, with a possible outcome of pumps malfunction, overflow of the intermediary cisterns and tanks for gas oil, etc. I'm showing you this map on the slide. I will be briefly speaking about the vectors of the attacks that we were thinking about, were able to detect quite successfully. So the first thing we detected was the connection of the new hosts to the actual network. After that, we were able to detect the attempts to get the password and other attempts to get access to the controller. So there was another possible event that we were able to detect, which was sending the control commands to controllers like stop, start, initiate. And there were attempts to send commands for loading and unloading. We tracked them down as well. Another vector here, another vector of attack that we were able to trace, which was not only the network related one, but also there were a few attempts of a malicious attacker or some changes of the engineer.
Раз. О.
So another vector of a possible attack was, or maybe random activities of an engineer, was the loading of the wrong software to change controller's logic. We detected that while checking the control sums and benchmarking it with the template one, which is stored in memory. It's important to note that such activities can be either malicious and deliberate attacks, but they can also be random mistakes and errors caused by personnel. In that particular site, such incidents were detected. Those were not attacks, those were faulty actions, and they were prevented. And there were more specific attacks or events that might happen. There were attempts to change the gauges tolerances, so the operator might see that the capacity is not reached and the vessel is not overflown, but in actual fact the level of will be much higher and the vessel will be definitely overflown. so it will be leaking out of it, and we might need to detect it as early as possible so that we find the root cause and adjust the process as necessary. And yet another interesting specific vector as the change of the PID parameters of the pump, which regulates the RPM of the pumps that pump the gas oil through pipelines. If it's not done properly, the RPM may vary. The RPM of the pump may vary, causing great vibrations. So the pumps will be shut down automatically, and it will shut down the whole technological process. Those I mentioned, there were just a few things, and we're thinking about creating a more sophisticated logic, checking separate parameters. I'm done with the description of this particular case. Maybe you have questions.
Так, обратная.
You were asking about the feedback. My answer would be that we react manually. If some network events are detected, we do it manually in order not to impact the technological system's performance. We notify the operator or the security staff with all the parameters required and some technical specs so that they will be able to take actions and understand whether it's an attack, an abnormality, or a normal event which is not yet prescribed in logic, and we do it manually for that reason. Will you give me a hand answering this question? Maybe you will help me, Evgeny.
Да, в рамках этого.
As far as this project goes, we had a partnership with partners thinking about the possible technological breakdowns, so that we needed to know that to understand the logic of the controller. So we did that with the technological stuff as well.
Ну, если
Speaking in terms of the technical, as far as technicalities go, there was this company which wanted us to make it aligned with the vendors, and there was this component that operates on a SPN port that needs to understand the protocols. Whether we need to align it with a vendor, I don't know. Maybe we should do it with the integrator.
И вот Леонид Эткин, он будет чуть позже выступать, он как раз от компании Эмерсон, он расскажет о том, как мы взаимодействуем. Но мы взаимодействуем не только с Эмерсом, конечно, понятно, что мы работаем и с Сименсом, и с Роквеллом, и с EDB, с другими вендорами.
Да.
Можно очень короткий вопрос на уточнение. В четвертом сценарии контроль целостности осуществляли чего? Конфигурационных файлов, программное обеспечение, значение базы данных.
Контроль целостности.
The control of the integrity of the SCADA project.
В четвертом сценарии речь идет о контроле целостности проектов, которые нужны в ПЛК, то есть программы, которые работают в управлении фронтами на ПЛК, и которые, собственно, выполняют логику, автоматическую логику технического процесса. Спасибо.
Коллеги, а сколько еще представителей лаборатории Касперского в зале?
Еще вопрос. А какими нормативными документами по информационной безопасности пользуются лаборатории Касперский при разработке своих программных продуктов? И что с сертификацией?
In Russia, we've been using Decree 31. But you mean, what do you mean to use documentation to develop a software? I mean, what kind of requirements we have for such class of systems?
Мне, да, есть что сказать про...
Yes, I have something to speak about certification, and I will take these questions later.
Коллеги, добрый
Good morning, ladies and gentlemen. I would like to welcome you. I'm Vladimir Karantaev, the manager of the scientific research Infotex. I would like to start analyzing the statement that we say it's time to react. It's time to react. How are we supposed to react? And who are we going to partner with? What will be the benefit that we might want from this technological partnership, and which technology we are likely to use here? I'll be very grateful if the statements will be supported with a discussion in the end, when all of the colleagues of mine complete their presentations. This whole industry makes us want to make a huge leap forward. So let me explain what the uniform power grid of the Russian Federation looks like. It's a huge facility which was originally designed more than 60 years ago, and lots of the components have so far become obsolete. In 2011, a possible next step may be a very active, adaptive power system, smart grid as we call it in English. And without new technology, this high quality leap forward is not possible. Introducing new technology is always related not only with the technological risks, but also with the risks of the information security, and we saw it yesterday, and we've seen it at a number of the events like this one. The vulnerabilities are an integral part of the technologies that are to be applied. I would like to say a few words about the foundation of the power grid, the so-called digital substation, which is a topic of heated debate. I'm showing you an optimized layout of the architecture of the digital substation utilizing the MAC 61850 standard. A few levels are here at the substation. You can speak about the so-called information data exchange, which is using a multicast protocol, and the vertical data exchange with the same protocol involved in the and MMS server protocol. Each of the protocols, as we have been shown by the researchers, can be exposed to different types of attacks. Tackling possible methods.
Организаторы. F5 там нажмите. Переходя к рассмотрению
Might want to tackle the methodological base that will help us build and use such facilities. We have assembled a number of best practices existing in the Russian Federation. In my presentation, I would like to speak about MAC 61351 standard, IEC 6. Speaking in terms of the interoperability of such standards, 61850 and 62351, I should be speaking about the standardization of the protocols. These protocols require specific requirements with 4 to 10 milliseconds latency, depending on the type of the object, depending on the type of the signal. I would like to say that the recommendations of such standards are about real-time protocols, MMS protocols, and 101 and 104 protocols. It is still considered which protocols may be used in Russia. In this standard, we're using Western algorithms and realizations, so we need to achieve harmonization of this standard in Russia. And by applying the recommendations of the Committee for Standardization, we may standardize the cryptographic requirements according to the Russian standards, and I would like to show you our approach. The customer is much interested about standard solutions, like it happens today, with high availability. The cryptographic solutions are not the easiest thing to do here, but we might want to come up with a cryptographic protection, and such SCADA solutions may be integrated in the relay automations and other subsystems, because the digital substation includes lots of subsystems, different subsystems. A differentiated approach will be applied here depending on the requirements to the protocol. In the lower part you may see the process bus with the critical latencies and delay requirements. You can show the Russian ghosts requirements here, MMS protocols. The standard implies encryption in transportation, and such recommendations do present here. We have all of the chances to implement this concept, and the ending statement of mine I would like to express will sound today: only with the full cooperation of vendors, those who are in charge of information security, integrators, SCADA integrators, can help us achieve the desired outcomes and implement them. Specifically, by heavily involved in pilot projects, we are likely to achieve the understanding that some of the components of these systems are not necessary to protect. So maybe some analysts are here, but I know that we have a very clear assessment system in the grid. So I think the right way will be to integrate the protection solutions into a comprehensive solution, so it will be analyzed and evaluated like all the other equipment, so that we can realistically evaluate the system and bring down the costs of the implementation, maintenance and support of the products that I mentioned. So some of the colleagues of mine previously expressed an opinion, like he's been saying for a couple of days, security experts have caused a lot of problems protecting themselves against researchers. So we need to cooperate and join the experience and do these pilot projects together. Thank you very much.
Как я понял из вашего доклада, основное предложение, вы предлагаете в рамках периметра подстанции использовать шифрование.
Ну, я бы сказал, да.
Вопрос. От каких, опишите сценарии или угрозы, от которых поможет защититься внутри периметра подстанции шифрование?
Ну, я честно...
Well, honestly speaking, I just mentioned encryption once when I was mentioning encryption in transportation. I was talking about base function of encryption into automation solutions, and I started with the technology, the protocol, communication technology, which is using this standard vulnerable, like for example multicast protocols, etc. So the substitute of the commands, and let me explain it more in detail. Now we have a clear trend to improve the automation of the power systems. The first trend is automation, then the adaptive network. So without actually creating the uniform trusted space, we would not be able to guarantee the monitoring of the power objects, power facilities, because they're all scattered around Russian Federation. So the attack may not occur from the perimeter. What's the digital substation, by the way? It's the substation where the information data exchange, telemetrics, etc., utilizes digital protocols. So the substitute of a command which will initiate the high voltage equipment may result in disastrous consequences, as you may understand, as you may imagine. The more critical thing here are the signals that are on the process bus from the transformers, etc. Some time ago, such samples were introduced. A short while ago, I believe it basically answers your question.
Но из определенных пределов сейчас переключиться. Предлагают решать, ну не все, да, но некоторые проблемы безопасности с помощью
Мгм.
как бы вот здесь решаться классические проблемы, такие как протухание сертификата, замена сертификата.
Хороший вопрос.
Не можем ждать годами, да, там перевыпуск, УЦ, вся
Не-не.
PPI инфраструктура.
Я понял.
Я же не говорю про PPI инфраструктуру. Как здесь будет участвовать, как это вообще проблема предполагает?
Вопрос хороший. Если можно, я начну отвечать.
It's a very good question. I only had two right statements. Well, in actual fact, it's a right question. Honestly speaking, I wanted you to ask such a question. In the slides when I showed the protected infrastructure, there were no components showing the PQI infrastructure, etc. And we understand that these solutions would not be just made up of the cryptographic modules. At the higher level, we need to have an infrastructure, which we actually do have. This infrastructure will encourage the support of the business cycle, the certificates, the keys. Your question was mainly related to the Russian realities, the validity of certificates and so forth. I mentioned that effective interaction of all of the parties, I think, will be able to convince the regulators that the topics like lightweight encryption, industrial certificates, possibly at some stage will be reaching that. But as for a particular solution, we have a highly performing cryptographic server which manages the life cycle of the keys. We just didn't show it in the presentation deliberately. Actually, I'm open for dialogue.
Множество раз сталкиваемся с ситуациями, когда поступает возникает проблема безопасности, все они идут корнями в наружу. Когда-то давно об этом не подумали. Потому что это протокол в 2003 году, по-моему, первый. 2003 год — это уже время, когда уже люди знали о том, что есть криптография,
Тезис хороший.
It's a nice statement. I would like to say, maybe that's my answer. Vulnerability is in the industrial Ethernet. And we have a trend, and maybe my colleagues support me, security by design. When the SCADA vendor builds up their solution with the integrated security features, including encryption. I may give an example of Schneider and Rockwell, where the controllers have got encryption modules embedded. We're currently speaking about SCADA and OPC servers, but anyway, why don't they do it in the first place? Well, I don't know, maybe. Yes, I agree with that.
Но есть
There are some business drivers. 850 dates back, but now, as far as I know, there is a third version. 62351 is still incomplete, and I think somewhere in the IEC one they realized that problem and started thinking about that. So I don't know whether we'd be able to cross out a 10-year-long story of a standard and just start talking about the new technology coming to life. But I think we may speak about liquidating the vulnerabilities, and there are solutions available which we can apply, and interaction. And we need to move on, by the way.
Да, добрый день еще раз, друзья.
Hello again. I think I should continue the discussion related to this question. I don't see anything magical here about this question, because any industry has certain specifics like application security, SCADA or telecom, and such voices that we have heard. Let's do it, let's get together and do it, are nice. And I see people who understand what it looks like, and they speak to security guys, and then they go to the experts on technology, and it breaks down. By the way, SCADA topic is a very painful topic, and let me explain this. Normally, we have consultants on information security and vendors coming up. They say they have all the knowledge about the technological process, and they understand it, and they're ready to protect it like tomorrow. And they're nice, respected people, and they obviously should be respected, and we need to defend this. They join in, and the discussion starts either with the vendor or without the vendor. Some people speak about threats, some people speak about industrial security, information security, that border, and then they start speaking about standardized IT vulnerabilities, and they start saying a number of vulnerabilities is growing every year. So buffer overflow, code failure, standard IT threats that we threaten people year by year, and nothing changes. But when it comes to the actual operations, we speak about the threat, and they speak about reliability. And we can't seem to come up with a dialogue with them. Please don't take offense, but the security guys say that they don't understand anything about information security, but the operation guys think, I mean, these idiots, they don't understand anything about SCADA solutions. How come they join in with this protection if they don't know the actual process? And before we have a very effective room for dialogue, we'll be able to speak the same language, it will be very difficult to do something about it. Even now, we actually see that there are like only 2 people present here from SCADA topics, and all the other ones are about security. Yes, we may give it a try, and really do try, but with not much result. We just speak about the same thing with different words. When we can find some understandable things for SCADA experts and actually show how this threat is implemented, this project will get support from the security guys, from the operations, and from the business. When we speak about the threats of business in the language of the IT, we often see that all of the threats break against a very superficial knowledge of the process. Like our experience is showing us, and we know the topic quite well. We had projects in Russia and abroad. If we are able to find 3 or 5 vectors that bypass these functional protection mechanisms and affect information security, those that are clear to the experts and engineers, the project will see the green light. And without delving into production much, you can't reveal these highlight points. You can only reveal them with the experts who have been working there for 20 years. Of course, initially they speak about fraud. Fraud in technology is art, the art which has been polished for years. It's an understandable threat, but it's not cyber security, it's more related to the economic security. And such ideas about how to protect SCADA, I don't really know. In actual fact, who can raise your hand and say, I know for sure, I've known now how to protect SCADA systems? I don't think. In actual fact, honestly speaking, in the IT infrastructure, we cannot say that we have learned to protect it. It's, of course, a developed industry. We have security by design and other things. Statistics proves, but every second organization has been hacked, and the attackers in IT cannot be detected for a long time. So when we speak about SCADA protection, we need to not speak about how to protect, because in actual fact all of the intrusions should be revealed. If we can reveal them timely, if we see that the threat is there, it's a huge achievement. And I think we detected such threats for different industries, and we became more and more convinced that we don't have a universal solution for that. In actual fact, we have at least one critical point which results in a disaster. And those were the examples really where we could really establish a dialogue, understand what would be the great pain for technologists, how it affects the business. People from Bombardier Transportation can prove this. When you get access to managing the system manually, automatically the red lights light up and the disaster is prevented. And when we speak about digital substations and power grids, this blocking of the substation is the actual driver which results in the violations and disasters and catastrophes with fatalities. Yesterday and today there were lots of people trying to hack a digital substation mock-up. 2 times they were able to shut down some systems. In the real power plant, it will be detected, of course, on time, and this incident will be handled according to the standard instructions. But there are some talented people, and some of them are present here, who can do it in another way, and it becomes a real danger. What can we do about it? Yes, we need to protect. We need protection. That's a process. This process is a long one, a complicated process. But before we start protecting someone, let's just agree with this someone. And we need to protect SCADA. And this air gap is a myth. It's of course understandable. It's a real need of a contemporary business. These systems should be integrated. There's nothing special or specific here. There is deep understanding of the SCADA processes. It requires time. If you take a geologist and put them in oil production, they don't know much about it. Security experts also need time for understanding. So you don't just need to take a hacker which hacked a chemical plant and start asking him about a railway station solutions. It takes time without understanding the real threats, without showing these threats to the business representatives, to plan some real activities and build protection is a very challenging task. And the main thing for today is to actually start to learn and see these attacks, and we monitor it. We try to reveal specific threats for business logic. We try to reveal the general threats. These are the realities that we need to handle today, and these are the things that will be basing our SCADA protection strategy in the future. I think this is it. There have been plenty of discussion points, of course. But of course, before we start a discussion, we need to listen to our colleagues first. And we need to lighten it up a little bit. It's an interesting topic. We speak a lot about what's happening, so let's just look for some new ideas, make it more dynamic. Thank you very much.
Главные представители МСТП, вам не очереди.
Добрый день, Кристоф Андрей. Просто хотел небольшой момент добавить. Вот СТПшники и служба безопасности, кто занимается, немножко на разных языках разговаривают. Поэтому для того, чтобы наладить контакт, надо хотя бы, не знаю, там, словарь какой-нибудь. То же самое ГОС, отказ по обслуживанию. Когда скажет, что у тебя контроллер встанет, соответственно, слушай, контроллер встанет. Ну, тогда будет проблема. Соответственно, в этот момент надо как-то научиться на одном языке разговаривать. При пересечении. Вот, наверное, самая главная проблема сейчас.
А это, собственно, терминологическая
It's a problem of terminology. It's a very relevant one. For example, experts gather together and they use different terminology and they argue about terms, speaking about the same thing. As soon as they agree on terminology, they resolve this issue in a couple of minutes. Simple as that.
Здравствуйте, коллеги.
Hello, colleagues. I represent a person who doesn't know much about information security. I would like to thank the organizers for inviting the company I represent to say a couple of words here. By the way, everything that I was going to speak about has been mentioned so far. SCADA solutions, technological process handling is actually the protection of the equipment, and our task is the protection of the equipment, because any shutdown of an 800 megawatt block in a Surgut power plant would cost 10-20 million rubles per day. That's how much an outage costs you. So the question of why we need this protection is explained economically in a very simple fashion. What do those who use SCADA solutions use? This technology, the production technology, is developing at a slower pace than the IT topic, and those people that are in charge of the product, they need to think about gaining profitability. Initially, it had been isolated from the outer world, and people thought that it would resolve the problem. But as the systems were developing, as people wanted to get more information about that, information flow would increase. And today there is a very smooth integration going on of business systems and SCADA systems. The isolation of SCADA from the outer world does not provide enough security. Some hackers will inevitably hack the system without any outer connectivity. This problem has persisted for many years. We are not the first who tackled this problem. People started tackling that in 1962, and they joined into the WAB association that develop standards, issue certificates. And we have heard some questions and conversations about layers of protection, etc. Certainly there are standards applicable here and best practices as well. The WIB idea is that the more protection layers are around the system, the better. And the 5 layers should be singled out to provide maximum security. Definitely, it does not guarantee 100% protection, because 100% protection will cost so much that we will have to close down the facility. But the more the layers, the better, to put it simply. A lot of functions have already been implemented in the SCADA system. This is 1.2.0 level. the more critical one. If there is any threat getting there, it immediately impacts the technological process, results in physical damage, losses, fatalities. That's what's designed by default. The next level, the so-called DMZ level. The DMZ is important, but not as critical. It's related to the loss of data, loss of archives, shutdown of some applications. And the last one is related to the business processes and the implementation of a threat will not stop the technological process as such. I will not be speaking about this technology, protection technology. I will just like to say that inside state-of-the-art SCADA systems, they have their own embedded protection systems that provide some security when the outer threat is missing and when they're tuned properly. And like it was said, the implementation of the appropriate settings by the integrator of the SCADA solutions is huge. Information security of this system is not possible without those people who know the systems. Historically, inside SCADA, they have their own tools at the perimeter. A certain system protects it again. You may be recognizing some logotypes like Kaspersky. That's not by mistake. We are partners as far as the endpoint protection is concerned with Kaspersky. And the second thing that we are testing is the integration of the embedded tools with the infrastructure protection system. The security center by Kaspersky implies the joint work with SCADA at all levels. We have multiple questions about splitting responsibility, but the integration of all 4 levels into one information security field is a trend. We may be dropping some technological points, like it happened with credit cards when we just skipped the check period and we skipped directly to the credit cards. And the same is here. And by using best practices, international standards, we are likely to get to another level. We might want to discuss it if you like. There is one more point. These systems are split into 2 big classes, the SCADA PLK systems and the DCS systems, the integrated, allocated systems. In actual fact, SCADA PLK is less protected. They have fewer embedded protection tools than DCS. There may be a different approach used here, therefore. For SCADA PLK, it's hugely important to integrate at all levels. For DCS, the partnership of the vendor, the integrator, and the manufacturer of the protection solution is important. That's all I wanted to say. Thank you.
На самом деле у нас такая замечательная...
We have nice configuration. We may immediately ask questions to the vendors providing security and those who would like to use these solutions. I would like to ask questions to Emerson. Number 1. Emerson equipment uses different logic in production. Even if productions look alike, the adaptation of the equipment takes a long time. It's a unique process, and if it's fine-tuned, you'd better not touch it. As a manufacturer of such systems, do you really believe that there may be a solution, a universal solution, which will be operating on Emerson lineup, revealing such attacks and enhancing the security protection? That's the first question. And the second question, the position of the vendors. Very often we see conversations about security. Let's try this, let's try that, and they say the vendor would not allow. If you do so, there will be no warranty coverage. So it implies some active protection solutions. So what about these active methods? Are they really possible in SCADA solutions, or you only speak about the passive solutions so that you are not affecting the technological process as such? Protection with technologists is an interesting topic, but I would say that this is it's a misunderstanding. You need to partner with the SCADA providers. The Kaspersky solution, the overfill solution, is not the best one, because in terms of the business, it's a real big chunk. Those who do the protection parameters for ages, but it actually means that you need to study the system, how it functions in terms of technology, and you cannot encompass all of the ships and buildings with this system. You need to partner with vendors. If you ask this question about the vulnerability of the system, all the systems are vulnerable because they all use open protocols, Modpass, Profipass, industrial Ethernet, APC, two-way protocols that can be used to hack any system. For example, I was walking in a street and I was thinking, is it possible to shut down all the factories in Russia if they all use NTP protocol? Easy. If you use a satellite and initiate the time changes and the system will fix this, you will be able to send this command. But that's one part. And another part, will there be active protection, by the way? It's a real good question. Even our company has different systems. Working with Kaspersky Lab, we see that the implementation may be very different, and the actual software may be universal, and we don't see anything unusual here or unrealistic. But like you were saying, any project is unique, so the implementation and fine-tuning is very specific. Even if we take two systems, Delta V and Ovation, Kaspersky is using it endpoint anywhere, and we only test it on Delta V as a security system. Ovation is the next stage, but answering your question, the means and approach may be the same, but the implementations may be unique. I would answer your second question like this. As a SCADA vendor, we allow the customer to use all of the protection of the perimeter methods. Inside, we try to use our own methods. But in order to use the endpoint by Kaspersky, We use the testing for 6 months, and we do not install the updates of antivirus software, but we test it with the system compatibility, and only after that we'll give it to the customer. So some people just say no. Endpoint is a very limited thing. There is a lot less than SCADA, but as practice shows, the updates tested are very seldom installed. Well, the Emerson position is clear. We started this discussion, and may I ask a couple of questions? Let me define the rules. Let us just raise the topic and let anyone speak about it. Then our dialogues will turn into discussion. So Vladimir, will you please raise the topic, and I will give the microphone to Alexei, so everyone will speak about what they think about it. Am I right to believe, from what you were saying, that you use experience first and foremost? So that statement of yours that when working with vendors, you need to accumulate this experience is very important. We speak about it, but we never point out the risks we bear. We need to understand the risks, come up with a concept, and then need to develop a method to protect against these risks. And these risks have never ever been clarified by anyone. I understand the methodology, I understand the assets, the risks, and so forth, but it's a higher level question. Is it true that the discussion is over and you are just accumulating the experience? That's where you see the way to protect your critical subsystems. And it's yes and no. On the one hand, the use of such systems exists worldwide. It's a current process. And second of all, what the vendors do, like Kaspersky, is a completely different thing. It's to a lesser extent related to technology as such. It's more related to IT. So our experience is more conservative. We learn the experience and we implement it. For more heated debate, seems like that everyone is offering monitoring solutions. And we've been watching for 2 days how everything is functioning in real life. Okay, we see this traffic. Okay, we see control commands, protocols, but we don't actually see the model of the technology process that we are trying to protect. We cannot say much about whether these parameters are legitimate. In order to come up with this model, we just need to maintain the security and simulate this whole process. Is that really the right way? Is that really the right approach? Maybe we should do a few contours here. I think, well, I'm not going to impose this statement to anyone. I spoke to Andrei about that. That's about the interaction of the security people and the technology people. There will be no such interaction unless or until it's defined by legislation. For that simple reason that for technologists, information security is not their business, and the process are continuous. Process continuity is more important. We may discuss our agreements, but we never agree. Like, for example, if you take this NERC standard, it's mandatory. Power generators know that if there are such and such violations of security, they will be fined for them. And only on condition of that, such systems will be implemented. And answering your question and continuing this topic, I think that the further we go deeper into SCADA solutions, and if we take, for example, this solution by Kaspersky Lab and a similar solution from Positive Technologies, this system should be, to a bigger extent, a system that is adjusted and monitored by technology people for the sake of technology. For example, if we compare it with telecom, there may be some famous DDoS protection solutions do the monitoring functions, and they help the telecom providers, internet providers, monitor BGP and other operators. The same applies to SCADA systems. These systems that provide security at a lower level should be monitoring the technological processes, and they need to detect abnormalities in the information security. And on the verge of the corporate segment, it's much easier. I would like to say one thing. In actual fact, it's all about the money. Because what's this threat like? There may be a physical threat, and you may be threatening the equipment, the people, but ultimately it's a threat to the business, and it's a threat to the money. It's a money-related threat. So what's more beneficial? You invest $1 million into a simulation, or just wait and see how much it's going to cost you if the equipment shuts down. Of course, there is software, high precision software, which models these processes with high precision, like 3-5%, and these systems are implemented, but they do cost money, and they need to be maintained, and the costs are very high. Well, in theory, it's all possible, but the question is whether it's really required. Any business would say, if there's no legislative requirement, why should we do it? Doesn't make sense. And that Decree 31 was implemented as a mandatory, or maybe a not mandatory, voluntarily event. We don't really know what to do with it. There are no prescriptions given, and everyone is trying just to study this issue before we have any legislative musts. It will be just an idea. So this technology is real, it does exist, and most of the vendors use the high precision tools, and separate companies apply this. It's just a matter of the money. So I would say that we do not offer monitoring systems, but I'm far from thinking that if only you use one technology, you'll be able to achieve a comprehensive effect. So I would say that there may be some advantages achieved through technological partnership between vendors. Some of them can do one thing better, some of them can do another. So with this technological partnership, some synergy effect may be achieved. But some colleagues that I would like to disagree with speak about this vertical market, that there is this dialogue missing. In actual fact, dialogue is not missing. There is dialogue, and it's becoming much more active. Even if we speak about specialized events, where it was just mentioned a couple of years ago, nowadays in the Russian International Committee there is a special group sitting, and it establishes a very nice room for discussion. There is dialogue, and there are more rooms for such discussions, and the more the better. And statement number 3, the legislative base is a very important and profound driver for such solutions. And when we were discussing whether this it's mandatory, we started a very high profile work, and we started setting industry standards, and I think that will be just the next step, and we'll just confirm this statement that it's time for us to act. Whether we should establish a dedicated monitoring system, we need to create this system, because this SCADA system has its disadvantages. The industrial system has its disadvantages, so we do not trust them. We need to develop an allocated system with different requirements. Security experts monitor it. It studies these events at a lower level, collects raw traffic, and you cannot cheat on this system with some spoofing. It's less exposed to the attacks of the controlled system. It shows more reasons why it's happening. And in the industrial systems, it's not a unique trend. We do see different solutions in different aspects. We do use them, and we need to have more in-depth analysis, more visibility of what is happening in the grid. If we just take a look at the interface of a SCADA system, we will not see many of the attacks. We will see some negative impact, but it may be misleading. The monitoring systems are more independent. It's more difficult to do with that. We need to provide some proper logic. This is the work which is considered to be very necessary. We do the things what the SCADA systems cannot do. Let me disagree with a few statements. First of all, we just started talking about the system for the security guys. We do not create this system for the security guys. We do it for those who operate the assets. That's number one. Number two, it's the statement about that we need to create a trusted system. Well, this trusted system is a very vague definition. The vulnerability is by different vendors was a trend which has happened a number of times. So I wouldn't say that we create a trusted system, but we need to create a monitoring system, and we should bridge this gap between operations and security guys. You show an asset with IP, with Mac, with the software, and it's not patched, and they will come up with a card and do like they were taught to do. So this approach should be very adaptive. When we speak about the protection against cyber threats, very often something happens in the network and we don't really know what it was. If we had this magic box which registers all of the events and provides it in a very cohesive way and put it in the language of the commands, it will be very nice. So there should be two representations. A representation which is understandable for the security expert and the technology expert, which is why we realized a project with Bombardier Transportation when we made a few mistakes, very painful and obvious mistakes. We wanted to create a dialogue between those who really use these systems and those who try to hack these systems. And we worked with Bombardier for a long time trying to understand whether we were right, and would like to thank the colleagues for involvement and participation. Anton may speak about it. In this current paradigm, some active methods, traffic blockings in a current stage of the evolution is not possible, just like creating a magic solution against anything. It has not been created in IT and it's unlikely to come up with SCADA systems. We'll just speak about some functions based upon business logic and understanding of the threats that result in industrial problems. So I think this is it. I would like to give the floor to the next speaker. I will show you my vision of the situation. There was this statement saying that there is no legislative requirements, there is no dialogue. In actual fact, there is dialogue. And apart from the information security companies and vendors, not much was said about the actual users, because Order 31 and the concept of the information security poses the responsibility on user, puts the responsibility on the user, makes the user responsible. We had a unique project when the organization initiated that based upon the institutes. They created an expert center, expert facility, and those experts invited us as developers and the Positive Technology company as experts for information security.
С точки зрения защиты АСУТП, мне бы хотелось обратить внимание вот на те особенности.
I would like to address some specific features that are very often forgotten by the security experts. First of all, SCADA resolves the functionality issues of the technological process in terms of the functional security. And they use a bunch of methods, a bunch of measures and means. And they spend quite a lot of time, a lot of money on that.
Так, влезть в технологический процесс, что-то встроить в систему, которая эксплуатируется уже много лет, сложно по двум причинам.
There are two reasons that make this quite complicated.
Что ваше средство защиты не сломает то, что есть.
To prove that it's not going to destroy what has been done already. And second of all, there is a problem with the actual use of the protection solutions by those people who use the machinery and they're not experts of the information security. So therefore we use this joint project on cybersecurity, and at the current stage we thought that the monitoring system should not anyhow impact the technological process, the existing technological process. The functional security reacts to the random threats, and SCADA is a very nicely tuned and nicely functioning mechanism in that respect. And information security threats, as we see them, they are targeted, they are very specific. They have a person behind them, a fraudster. The monitoring system helps separate random impact from the deliberate impact. When the fraudster uses the information channel to impact and damage SCADA. One final statement. We heard a lot of ideas about encryption, good ideas about encryption. Unfortunately, we would definitely like to use encryption, and we've been thinking about it. But today, we've seen two key problems to using it. First of all, the hardware-related problem. There's no hardware which is suitable for industrial requirements, IP, mechanics, climatics, etc., which is important for a SCADA solution. And second of all is the maintenance and usage, how to teach the staff, the personnel, so that they do not just replace one block for another one, but they need to do something specific for the tuning. That's what we need to do. That's how we need to work here to create the hardware-related part and the software-related part that can be nicely configured. Thank you. May I just answer these two statements, the missing hardware part and the operations. But as far as the hardware is concerned, let's just discuss it. We have such solutions and they can be discussed. And when I speak about integration, one of the targets was to simplify the integration and maintenance, and we can improve that. If there is such a need, we can do so, and we are ready to support this dialogue. I think we need to continue. Let us just start one more round, and then we have Vadim Podolny from Rosatom. who we're going to give the floor, and I think it will be a very interesting presentation. Here is one provocative thought. We all speak about monitoring, the need for monitoring, information security, etc. The 2 days, if it was not for their help, if it wasn't for those experts who understand the technological process, those people who have access to the monitoring consoles, we would not be able to provide security properly. So let us just try and understand how this monitoring system should be operating. Should there be two separate systems, or it should be a uniform monitoring system of all of the parameters, like security, for instance, and with different analysts, security experts. So what do you think about it? With separate security, or it's the uniform monitoring and control system, which includes technological parameters and security? Well, I think last time I mentioned that at a lower level, starting at a controller level, for instance, the systems, like some of the colleagues had proved, should be managed by the people from operations, and I think our colleagues may prove what would be the percentage ratio of the technologists and the security experts involvement, and I think the technological experts will prevail there. I spoke about that previously. I think here these monitoring tools should perform very relevant tools like systems monitoring, imaging functions, etc. There was one statement about poor interaction with the technologists. My opinion was is that we do not work together and on vendor uh, who discusses it. Let's just say a couple of words. Then give the floor to Vadim.
Показывали схему автоматизации, защищенной с помощью HIT. И вот я там не увидел сервер обновлений, который бы раздавал обновления на армы, на сервера. А ведь вы предлагаете АСТПшников, которые сопровождают систему, все эти обновления ставить вручную.
Нет.
Это безумие.
Мы говорим о сервере обновлений там, для наших компонентов или для там...
Не для ваших, для АСТП. Вот просто показано, то есть вот защищаем, вот мониторинг, и типовые сервера. А это ключевой вопрос.
Безусловно, когда компании-интеграторы делают комплексную систему защиты, они должны это предусмотреть. Мы показали фрагмент, сделанный с использованием наших средств. Безусловно, компания-оператор технологического объекта должна рассмотреть больше. Да, это всего лишь там два эшелона каких-то мы закрываем. Мы закрываем рабочие станции, закрываем сеть в плане мониторинга. Здесь ничего не написано, не рассказано про межсетевое экранирование, про аутентификацию, да, там, про другие методы, да, в том числе нормально выстроенные процессы обновления. Я про это не рассказывал. Это как бы комплексная задача защиты владельца объекта.
Можно я добавлю?
Да, это надо.
Очень хороший
Очень
вопрос,
кратко.
потому что патч-менеджмент, автоматический патч-менеджмент, это один из краеугольных камней, собственно, обеспечения безопасности. К сожалению, у нас эта функция есть, мы ее предлагаем, но, к сожалению, та же Роснефть имеет в своем регламенте безопасности запрет на внешнее подключение. И Газпром тоже. Ну и все. Вот на этом и закончилась автоматическая раздача.
Ну, мне кажется, сильно рано говорить про автоматическую раздачу патчей, пока они даже в ручном режиме не ставятся на критические узлы.
В ручном режиме ничто не мешает. Но ручной режим мне ничего не спасает, опять же.
Nothing saves the manual mode. Thank you very much. I think there have been some technical issues, and we've overcome the technical issues. It will be difficult to speak about the use of the monitoring solution. Who is supposed to be using the automation system, automation solution? Answering this question, I should rely on my personal experience working in the metallurgical sector and power generation. Everything depends on the expertise level at a particular facility. It depends, like we say. In different situations, it happens differently. I've seen lots of cases in the metallurgy where there have been huge automated machines, and they're responsible for that. So naturally, it's very difficult to come up with a specific answer. We only have 15 minutes left. We just need to finish this, and Vadim will be closing this session.
Многие вопросы. Слышно всем нормально? Значит, меня зовут Вадим Подольный. Я заместитель технического директора компании РАСУ, это Росатом автоматизированных систем управления. Одновременно директор двух департаментов разработки программного обеспечения и департамента кибербезопасности. Собственно, мы решили объединить вот эту деятельность в единую, потому что кибербезопасность это фактически большая такая часть разработки программного обеспечения, особенно программного обеспечения, которое касается промышленной автоматизации. Фактически, можно увеличить тогда. Что с ним, что без него одинаково абсолютно. Фактически.
In actual fact, we're developing a software platform which provides integration of all of the components we acquire into the uniform system, and the cybersecurity wants to create a trusted system from the non-trusted components. So that's how we set up the target first. So let us speak about what's this atomic power plant all about. And here I would like to give you a few characteristics. Dozens and dozens of suppliers, controllers, thousands of sources of signal, up to 200 changes of the parameters per second may occur. So, another thing, this concept that I'm speaking about has been agreed at IANA event in April, and we had a very interesting event which was run in Vienna. We had some representatives of vendors, we had representatives of the consumers from atomic power plants, security officers. We had developed a document which is supposed to replace NST 36, the main regulations for security in nuclear facilities, atomic energy. So they wanted to create a standalone document on providing the cyber security in atomic power plants, and this whole document is circling around splitting the different contours. So there's a contour model of the atomic power plant. Just need to point out that there is one specific feature here. We have the isolated contour, and we don't have the external disturbance. It's all connected with cables. We don't have any information sent by air. It's an important thing to consider on how we need to provide cyber security. And in actual fact, we split it into 5 zones. The automatics, the contour which unifies it in a protocol, where we have the operational contour, where we have the operator sitting there, and different other stuff that monitors everything. And that's the contour which holds the technologists and the remote access. So all of the contours, starting from where this management is missing, all the contours are split by gateways, and that's the basic concept which is defined here. So basically at each contour we have our own threat and protection model. So the main task here is to provide cyber security, provide continuity, efficiency, and security of the technological processes. We'll point out the classic control block reactor. The leading engineer of the turbine area is here, that's where the turbines are sitting, and here's the senior expert who orchestrates all this process. And we have the technological process which is running here. Here is a classic layout, a classic map from Russian Railways, Rosatom. What cyber security is all about? Cyber security is the actual understanding of the security, cyber security.
использовать термин кибербезопасности, они используют термин computational security. И упорно не хотят применять термин industrial. Очень важный компонент во всей этой истории – это secure by design. Это такой международный термин, который сейчас, в принципе, у нас в весь используется. То есть это создание защищенной системы при проектировании. При проектировании вносятся все проектные решения максимально, которые могут максимально обеспечить защитное качество системы. Как раз я отвечу на предыдущий вопрос, что разделяем ли мы систему АВТП, систему безопасности, например, нет, для нас это единая система. Мы говорим, что оператор видит события информационной безопасности, также такие же алармы, такие же тревоги, которые срабатывают по своим типам и видам уставов, так же, как и тревоги внутри самого АВТП и тревоги технологий, которые происходят вместе работы технологического процесса. Мы говорим, что угроза может возникать в том случае, если мы интегрируем несколько компонентов в единую систему. То есть, если, например, производить исследование того или иного компонента на безопасность, то есть исследовать исходный код, исследовать пентестинг, что-то еще можно ничего не найти, но как только ты сопрягаешь в единое целое, мы можем получить нехорошую ситуацию, активируется какой-то кейс, который приведет к каким-то серьезным последствиям. Поэтому мы выделяем как исследование отдельных компонентов, так и исследование системы в целом. При подготовке к вводу в эксплуатацию на блоке присутствует огромное количество технических специалистов, экспертов, которые, можно так сказать, тюнят станцию перед тем, как она будет запущена. Происходит какое-то обновление оборудования, обновление компонентов, обновление программного обеспечения, тренировок и так далее, и так далее, вследствие которого может система что-нибудь должен попасть, поэтому и разрабатываются, и постоянно улучшаются регламенты, которые позволяют исследовать все эти компоненты в ускоренном режиме бороться нужно именно с ним. И исследовать именно его. Вот как вот тут тоже уже звучало, такой термин доверие, да, то есть что мы делаем? Ну, мы повышаем доверие к системе. Мы строим доверенную систему из недоверенных компонентов. Что мы можем сделать внутри? Внутри мы можем исследовать исходный код на MSD НДВ, мы можем исследовать исходный код как программного обеспечения платформы и компонентов системы верхнего блочного уровня, из которых мы собираем. Мы можем исследовать прошивки какие-то контроллеров и так далее. Да? В данном случае применяется классическая схема тематических исследований по НДВ. Это потому что отработана уже нами схема, максимально схема, максимально сложная схема для исследования. Мы проводим статический анализ исходного кода, мы проводим исследования на наличие опасных конструкций. Мы его постоянно перечень обновляем. Мы знаем, какие для нас опасные конструкции могут нарушить реал-тайм процесс, мы знаем, какие опасные конструкции могут нарушить безопасность технологического процесса. И тут возникает коллизия. То есть можно как-то оптимизировать, потому что сделать безопасно и быстро не всегда получается. А скорость для нас важнее иногда, чем даже какой-нибудь там мелкий отказ программного обеспечения. Это динамический анализ программных компонентов. Тут вот все методы указаны. Фактически, если даже вот так посмотреть, то во всяком случае сама программная система, которая работает на блоке, она работает и так в режиме DDoS. Она DDoS-ит вот этими пакетами информационными и информационно-управляющими серверы АСТП информации. Да, фактически мы живем в этом режиме. Поэтому главное нам следить за объемом трафика и пытаться находить какие-то нестандартные пакеты, вот которые мне кажется, значит, мы делаем сопряжение с интеграционным и нагрузочным тестированием. И если где-то у нас возникает ситуация, где мы не имеем исходного кода, но мы очень хотим понять, что можно, в принципе, даже если засимулировать или вот заказать реверс инженеринг, или как бы сделать реверс инженеринг в таком виде, чтобы можно было сказать, там есть внутри или нет. Да, не всегда нужно понимать полностью логику, достаточно просто применить вот такие механизмы. Да. Также про реверс инженеринг хочу добавить, что мы сейчас стараемся разделять все системы через LLVM, чтобы все языки, на которых у нас разработаны те или иные компоненты, генерили промежуточный LLVM код, потому что его очень легко исследовать на НДВ. Это
дискуссию, там, поговорим про мониторинг твайка, 3, 10, 1 или 8. Давайте выйдем за пределы зала, пообщаемся отдельно на эту тему.